I can't make the decision to halt the relay chain and start the jam chain and move everything over. This is a decision that should be taken by the community. And so one of the things that I'll be doing is putting out a proposal for a governance motion that basically doesn't say implement this and deploy it and we're done, but rather says this, as it's described, is a reasonable direction, and we, the Polkadot community, the dot token holder, gathered dot token holders that whose plurality commands governance, we ratify this as the direction we want to go in with Polkadot. And what does that mean concretely? Well, it means allowing the Polkadot Fellowship, or rather bestowing the Polkadot Fellowship with the responsibility to finalize this into a protocol. Bestowing on the Web3 Foundation the clarity that it needs to support and sponsor further development of this, in particular implementation teams. It means bestowing on the fellowship the responsibility to create the service and the migration tooling, this parachain service and the migration tooling that will make Polkadot version 1 or whatever, the relay chain, compatible with Jam. And it means bestowing on the fellowship the responsibility of halting the relay chain and starting the Jam chain and basically looking after that migration when the time comes and dictating when that time is. So basically it's a, yep, we're up for Jam, and fellowship, make it happen. In part, it's up to me to convince other people. In part, it's up to me to, up to me and for that matter, other people that are working on this broad project to respond to needs and comments and maybe move it in the directions needed, such that it makes most sense for its users.
Will you be voting on it?
Yeah, probably. I mean, I feel pretty strongly that this is a good direction to go in. I mean, if it doesn't get ratified, then it's not the end of the world. I mean, I wouldn't see Jam as something that I wouldn't do. Like, I mean, I'm going to do Jam anyway. I think it's sensible. I think it's a sensible thing, and I think it opens up a lot of doors that would otherwise be closed. In particular, this semi-coherent is what I'm calling this idea of agile partitioning of the state, semi-coherence of the system. I think it opens up some really incredible doors. I mean, one of the things that I think is some people can get quite excited about is some sort of zero knowledge roll-up host that would basically reuse Jam's data availability system for ZK rollups, and this would provide potentially a path to. I mean, I don't know. I'm not super optimistic about the prospects of ZK rollups as scaling solutions, but it provides for the possibility of ZK rollups becoming efficient enough, performant enough to efficiently scale, to sensibly and at a reasonable cost scale consensus systems. So that's on the one hand. I can imagine services that do storage services, but do so without the need to have blockchain validators. I could imagine many of the things ultimately, maybe not on day one, but ultimately many of the things that we use blockchains for to be able to be done as Jam services, and to do so with much more, a lot easier than it is to develop and deploy a blockchain at present, without having to worry about validators and all sorts of stuff. One of the things that I'm most excited about is CorePlay. This idea of putting smart contract code right directly there on the cores. Now, CorePlay, I think, brings a number of things other than that. In particular, with Poker VM and its sensible memory model, it allows for the possibility, basically, of running regular code on a blockchain. Regular, normal program code that people just write on a blockchain, like C, C++ programs that do, I don't know, random stuff. Regular console applications, just put it on a blockchain. It allows for that level of performance, but most crucially, it allows for the ability for these programs to be temporarily halted, memory fetched in, pages swapped in and out, with utilizing the distributed availability system. And if my more recent changes to this stand scrutiny, also the ability to basically keep their memory inside of the Jam's distributed availability system. So basically keep this virtual computer's memory that this program, this regular computer program is running in, inside of the Jam distributed availability system, which means there doesn't need to be extra validators. There don't need to be an extra blockchain. There doesn't need to be extra collators. There don't need to be these actors that you somehow have to incentivize to keep your data around and feed it to you and build work packages with it. It would all be manageable from within Jam. Now, this is a little bit beyond what Jam is aiming for at the present, but this is something that I would hope during the evolution period, and perhaps, hopefully, fingers crossed, even in the next few days, it can be built into the Jam paper, and thus make with Jam this really quite, well, it would sit on Jam, CorePlay, but it would be this really quite general application hosting service in which you could put EVM contracts, but you could also put Rust programs and Ink contracts and whatever else you wanted to do. And they could all interact with parachains. And they could all go via the bridge. Right? Basically, most applications that we currently can imagine blockchain doing, and applications that we currently think would be way too either data I/O intensive or compute intensive, Jam could potentially make a reasonable prospect. Jam. So with Jam, it's really a push towards this original concept that I pushed out in New York in, I think, early 2015 or mid 2015. This world computer, a computer as a sort of unified machine. In this case, semi-coherent. That is scalable enough to actually compute significant amounts, like global amounts of transactive computation of data. I mean, some of the numbers that we're talking about here are very big. I mean, I did some back of the envelope calculations, and these come with a very, very, very large pinch of salt, because this will to some degree rely on engineering concerns as well. But I mean, we're looking at, if you look at the amount of Ethereum gas per second, it could be up to, depending on applications, up to about 1 trillion Ethereum gas per second that this, in aggregate, Jam might possibly be able to process. Like, it's at the higher end, but still. Yeah, so that's that. We're looking at maybe up to around. So I'd definitely say 500,000 times the EVM computation performance across Jam, and maybe into the millions. And PVM still has quite a lot of optimizations to go. So I don't feel that it's unreasonable to say into the millions. Now, it's a low bar to cover, just to be clear. No one in Ethereum is pushing the L1 EVM performance as any kind of highly performant machine, right? Everything in Ethereum is about what's being built on L2. Doing ZK rollups, the idea that the EVM on L1 probably is only going to be used to verify these rollups. So it's not that this is meant as a comparison to what Ethereum will be, but rather as a useful yardstick over how much better than this one chain and its various use cases Jam is aiming for. That's what Jam is targeting. Now, this sort of millions of times as fast as EVMs compute. I mean, it's not really millions of times as fast. That's probably pushing it because PVM executes over many different cores. But millions of times of the performance of the computational bandwidth is probably better wording there. Now, in addition to that, it's probably not probably, I can say exactly how much. So, I mean, Ethereum has around 78 kilobytes a second of input data, that basically data that it can take from the rest of the world, and that's assuming you don't use it for anything else. Jam, we're looking at around almost a gigabyte per second of data that can be fed in from the rest of the world. So again, it's not quite a million. Is it a million? No, a bit 1K to a gigabyte, wouldn't it? Yeah. So it's not quite a million, but it's in the tens of thousands of times the amount of data that it can bring in. Maybe about 10,000 times the amount of data that it can bring in and use, right? And again, it's like this isn't really a comparison to what I don't necessarily believe that something that is purported to be in the same generation as Jam can't do as well. But I do think Jam is the difference with a lot of these, with these systems that have yet to be built, is that they're based on a lot of theoretical assumptions. Well, Jam, most of this, like the vast majority, is based on what we've built with Polkadot. Like, we're not building much new technology. We're actually repurposing Polkadot, and to a large extent just doing basic optimizations on Polkadot. PVM is new, but PVM also is based on a pre-existing technology, RISC-V, and it's already implemented, and it's demonstrably significantly faster than EVM. And it's also reasonably easy to explain why it's faster. It's just much more in line with modern hardware. It's easier to make something go faster if it's already a lot closer to the thing that's going to be executing it. So yeah, I feel we're definitely going to be able to smash through the current performance limitations of blockchain with Jam. The question is, the only question in my mind is, what will be out there when Jam is delivered? And this is why I'm keen to get the ball rolling with this upgrade. Because if this ends up becoming, a sort of, oh, well, we could do this, and then we could do that, and then we could do the other, and then we have a really long time, going around iterating, then, the world will have moved on. And when Jam finally comes out, it may not be quite so, competitive. I think if we really push to get something finalized, if not implemented by the end of the year, then it's gonna blow everything out of the water in terms of performance. So, I mean, the first application is, of course, parachains. And this is why it's very important to continue the evolution of parachains. And there's going to be a bunch of stuff that Jam will facilitate for parachains, removing the need, or the absolute need for benchmarks within parachains. This is like a pain in the ass thing to do. I've written my fair share of benchmarks to be very, very glad that I don't have to write any more. It also introduces the possibility of using spree. This is the idea of having accords, essentially parachains that have portions of their logic that are non-negotiable, that are absolute and enforced outside of the parachain. So, for example, if a parachain has some tokens logic, it might be in the parachain's interest to say, I give up the right to alter this logic, I give up the right to change this logic without permission from everyone else that's using it. Or without some governance action that is beyond the control of the parachain. This is currently not possible. The only way you could do it is by putting that logic on another parachain, but then that, as we said before, synchronous composability, you lose that. So it's really handy to have the ability to have this logic sit in the same place as the parachain, so it's synchronously composable, but still not under control of the parachain. And that's what accords are, and that's Jam can do accords really very easily. Makes it very much easier to develop accords. So there's a couple of big things in it for parachains. It just makes sense. It makes sense on so many levels. I mean, I discuss some of the design decisions of Jam. I discuss with the researchers in the Web3 Foundation. Some of the stuff, obviously, I discuss with people that have already implemented similar systems on Polkadot to understand better, why those systems were architected in such a particular way, and help me understand which bits are important for Jam and which bits were incidental, were mistakes, were legacy concerns that are no longer important, were misunderstandings. And, it would be lovely to think that all code ever written was exactly as complicated as it needed to be and and exactly correct and didn't include any opinionation. But honestly, it's so far from the truth, it's laughable. And this is why formal specs are important. And it's why I believe it's important for Ethereum. They've moved away from the yellow paper. They were talking about moving away from the yellow paper for some time. Like I remember, I think even at the DevCon 1, there was talk of I think the Haskell implementation was the original. Let's move away from this formal spec. But some people felt that it was worth maintaining, and they continued to maintain it, which is cool. Makes sense to me. I think now they're finally moving to Vitalik's Python implementation as, the source of truth. But again, Python's a high-level language. You can probably make a case that it's not a bad candidate, but I think it's still nowhere near as much of a non-opinionated thing as writing it in set theory. That's right. So this is one of the things that the Web3 Foundation is looking to support. Many different implementations. I mean, with Ethereum, we wanted 3 different implementations when the network launched, and it's the same. Looking for the same thing with Jam. 3 viable implementations of this protocol. So it's a bit like suppose you have a recipe for a meal, right? As long as the recipe is followed exactly by, it can be 3 different chefs, but as long as the recipe is followed exactly, then you're going to end up with meals that should be, they'll be marginally different in some regards, but they should be indiscernible from each other, right? So if I get blindfolded and like take you make 3 different, I don't know, spaghetti bolognese, right? Spaghetti bolognese, spag bol, right? Easy. So you make 3 different spaghetti bologneses, but you follow the recipe exactly. If it's a good recipe and it's unambiguous, so it has to be unambiguous, has to be a good recipe. But if it's a good recipe, unambiguous, then you can get 3 different chefs, and as long as they're cooks, whatever, as long as they follow the recipe correctly, you can put these 3 plates of spaghetti bolognese in front of someone and have them taste, forkfuls of each, and they shouldn't be able to tell the difference of each one, right? There'll be different dishes, but they shouldn't be able to tell the difference in each one. And that's really what it's about. The different implementations of this have been made by different people. They could even use different ingredients, different languages. But as long as they implement this properly, and we have tests to make sure they do implement it properly, conformance tests, as long as they implement it properly, then you shouldn't know which one you're speaking to. If you speak to one of these implementations, you shouldn't know which one you're speaking to, unless it gives it away. But if it wants to not give it away, you shouldn't know who you're speaking to, like what implementation you're speaking to. And this is the thing. It's like because there is a high degree of likelihood that one of these implementations, every implementation is going to have a bug, right? Our assumption is that this doesn't have any bugs because this has been audited so much, right? It's in the open. I'm not going to say very intelligible, but if you can read set theory, if you're a theoretician, this should be fairly intelligible, at least for working out what something should do. It should be unambiguous. If you, in terms of correctness, right? If you take an implementation that properly that implements it but has a bug, it's not likely to be the same bug as in the other implementations. And this means if you have a network with nodes using a good spread of different implementations, even if one of those nodes has a bug and someone attacks it and they manage to make those nodes go down or go wrong or whatever, the other nodes should keep going. And the network as a whole is much, much more resilient. So the Web3 Foundation has funded development of 2 other clients, or 2 other implementations for Polkadot. And one of them is now at a point, I believe, where it can run a Kusama node and make blocks for Kusama, which probably means it can do the same for Polkadot, but they probably just don't want to risk it quite yet without testing it thoroughly on Kusama. So Polkadot's getting there, but it's not. I'm actually not sure where Ethereum is at the moment with its multiple implementations. I mean, back in the day, it had 2 that were viable, and plus Python that was a bit slow, and then I think there were some other implementations that came along, but I think there was a Java implementation that was pretty good. But I don't know where things are as it stands. With Jam, I want to make sure that there are 3 viable implementations, and indeed, that's in the governance proposal. Jam will not launch, like things won't move from Polkadot Relay to Polkadot Jam until there are 3 implementations that are tested, working with this specification. Now, this isn't something that has been invented for blockchain. It's something that happens all the time in safety critical systems engineering. So one of the most obvious ones that I know of is passenger planes, passenger jets. Their control systems are implemented 3 times by 3 different teams working to the same basic specification and conformance test requirements. The teams are, I mean, I don't know if this is I suspect it may even be a legal requirement, but it will certainly be a contractual requirement for them not to interact at all, right? They're not allowed to talk to anyone outside of their team about this implementation, because to do so, they might risk injecting a bug or an issue that another implementation has. And then on the plane, what it does is it has these 3 implementations for the control system that should do all the same, exactly the same thing, right? So when pilot pulls lever back, put fins down, whatever it is, they should do the same thing. But if one of them does different, it chooses the 2 that do the same. So it expects only one to have a bug only to be in one at once. It would really fuck things up if 2 teams chatted to each other, because that makes it more likely that the bug will appear in 2. And then, of course, if the bug appears and the machine that's the little computer's a little control computer that just sort of chooses the thing, all its job is just to choose the 2 things that are the same, right? If they're all the same, it doesn't matter which 2 they choose. If 2 of them are the same, one's different, it chooses the 2 that are the same. If 2 of them are the same because they have the same bug, then it's going to choose the buggy one, right? So it's really, really, really important that these teams don't collaborate. So Jam will have, like, one of the ways that we'll do this, we obviously can't prevent people from making nodes in Jam that implementations that don't draw upon other implementations, design decisions. But we're going to introduce an incentivization to Jam called the Jam Prize, the Grey Paper Prize. And this is for Jam implementations that are clean room, and that we find, we'll look at the code, and if the fellowship finds that there is no great reason to believe that the author has been looking at other implementations and bringing in those implementations design choices into this implementation, then it will be applicable for the prize. There are ways of doing this. One of them is looking at the history, the commit history, making sure that the commit history makes sense. People will often go down incorrect paths in the commit history as they misunderstand bits from the spec and then understand it later, and understand why the different bits, and then actually rewrite parts of the code. So we would expect to see this kind of behavior. So there's going to basically be judges that judge not only, there'll be tests to judge whether it's conformant with the spec and performant enough to run Polkadot, but there will also be judges that judge whether there are reasons to believe that this was a clean room environment. So clean room just means they just look at the spec and nothing else, or whether it's more of a derivative and they've looked at some other implementation and just translated that implementation into another language.